Hello, everyone. Welcome to the Quartz Foundation and Substructure Construction. I'm today's instructor, Wang Xiyang. Today, we will learn about the functions and the classification of pile foundations. These are our learning objectives. By the end of today's lesson, you should understand the concept and the classification of pile foundations, how to choose and apply them appropriately, and also gain a preliminary understanding of their design elements. Let me first quiz you. Do you still remember how shallow foundations and deep foundations are classified? If not, you can review the relevant section in your textbook. The skyscraper in the picture is Shanghai Tower, the tallest building in China, with a height of 632 meters and 128 above-ground floors to support its massive load. The designers adopted board casting plates, piles 947 piles in total, each about 56 meters long, with a diameter of 1,000 millimeters and a single pile bearing capacity of 10 kilonewtons. When you see these numbers together, the scale is striking, and the Chinese saying, "If the foundation is not firm, the earth will shake," truly conveys the importance of a solid foundation. From today, we will begin learning about the most common foundation type used in high-rise buildings, pile foundations. First, let's understand its definition. A pile foundation consists of piles and a pile cap. If the entire pile body is buried in the soil and the pile cap bottom surface is in contact with the soil, it is called a low cap pile foundation. If the upper part of the pile body is exposed above ground and the pile cap is located above the ground surface, it is called a high cap pile foundation. Building pile foundations are usually low cap pile foundations. Functions of pile foundations mainly covers the following aspects. 1. To gain bearing capacity by transferring load through pile side contact with the soil. 2. To pass through liquefiable soil layers and transfer load to stable, non-liquefiable layers. 3. To provide high vertical stiffness, reducing and equalizing settlement in buildings. 4. Piles have great lateral stiffness and uplift resistance, enabling them to withstand the enormous horizontal forces, uplift forces, and overturning moments caused by typhoons and earthquakes, thus ensuring the safety of tall structures and high-rise buildings. 5. To alter the dynamic characteristics of the foundation, increase the natural frequency, reduce vibration, amplitude, and ensure normal operation of machinery. Next, let's learn the classification of piles. 1. By bearing characteristics. Piles can be divided into end-bearing piles and friction piles. This is one of the more important classification methods, so please pay close attention. Based on the interaction characteristics between the pile and the soil under vertical loads, specifically, the degree to which side resistance and end resistance contribute to carrying the load piles are categorized into friction-type piles and end-bearing type piles. End-bearing piles are piles in which, under the action of the ultimate vertical load, the load at the pile top is borne entirely or primarily by pile end resistance, while pile side resistance is relatively small or can even be neglected. Depending on how much the pile end resistance is mobilized and its proportion in carrying the load, end-bearing piles can be further divided into frictional end-bearing piles and pure end-bearing piles. Friction-type piles are piles in which, under the action of the ultimate vertical load, the load at the pile top is borne entirely or primarily by pile side resistance. Based on the proportion of the load carried by side resistance, friction-type piles can be subdivided into pure friction piles and end-bearing friction piles. 2. By functional use, piles can be divided into the following 4 categories. Vertical compression piles, also called compression piles. these are piles that mainly bear vertical loads. According to the load transfer method, they can be divided into friction-type piles and end-bearing-type piles, the same classification we introduced just now. Vertical tension piles. Some of you may wonder, aren't loads usually directed downward? Why do we need tension piles? One of the most common reasons is that in some buildings, the groundwater level is relatively high. As we know, groundwater generates buoyancy. To effectively resist this buoyant force, tension piles are required to play their role. Laterally loaded piles. These are piles that primarily bear horizontal loads. In everyday construction, especially for super high-rise buildings, horizontal forces caused by wind loads cannot be ignored. In addition, considering earthquake effects, it is often necessary to design laterally loaded piles. Combined load piles. These are piles designed to bear both vertical and horizontal loads of significant magnitude. The remaining piles can also be classified according to the materials used, such as timber piles, concrete piles, steel piles, and composite material piles. Piles can also be categorized according to the method of pile construction and the soil displacement effect during the pile formation process into three types: non-displacement piles, partial displacement piles, and full displacement piles. According to pile diameter, they can be divided into small, medium, and large piles. And according to shape, they can be classified as a square, circular, polygonal, conical, rectangular, and so on. With so many types of piles, how should we choose the right one? In engineering practice, we mainly consider the following factors. 1. Hydrogeological conditions. 2. Engineering characteristics. 3. Environmental requirements. 4. Site conditions and available equipment. 5. Cost and schedule requirements. 6. Construction safety. Pile foundations are particularly suitable under the following conditions. 1. High-rise buildings or other important structures where large settlement or uneven settlement of the foundation is not permissible. 2. Heavy industrial plants and buildings with large loads, such as warehouses. 3. Soil foundations or permanent buildings on certain special soils. 4. Tall structures subject to large horizontal forces and moments, such as chimneys, water towers, or other situations requiring resistance to horizontal forces or uplift. 5. Foundations for dynamic machinery, where vibration effects must be reduced, or as an effective anti-seismic measure in earthquake-prone areas. Finally, let's briefly look at the key factors to be calculated and considered in pile foundation design. 1. Selection of pile type and geometric dimensions. 2. Determination of characteristic values of single pile vertical and horizontal bearing capacity. 3. Determination of pile quantity, spacing, and arrangement. 4. Verification of pile foundation bearing capacity and sediment values. 5. Pile shaft structural design. 6. Pile cap design. 7. Preparation of pile foundation construction drawings. In summary, in this lesson, we gained a preliminary understanding of piles. During your learning process, you should focus on grasping the concept of pile foundations, their functions, and their classifications. That concludes today's lesson. I hope you all found it beneficial. Thank you.